In this video, we're going to have a look at how to use a stem and leaf plot when we are calculating with our statistics. So the stem and leaf plot is one way of listing all of the data within a data set. So it consists of the stem, which is normally the first number or numbers within our data, and then the leaf, which is the last digit in our data. When we are using the stem and leaf plots, we need to refer to the key that's normally up the top to help us interpret what the values are from the stem and leaf plot. So using our key, we know that 1 with an asterisk and then a 9 is equal to 1.9 kilograms. So applying our key, we know that our numbers are going to be 1.9, 2.2, 2.4, 2.6, 2.7, 2.8, 2.9, 3.0, and so on and so on. So we can be using the stem and leaf plot as a way of reading our data when doing our calculations. So let's have a look at an example where we want to calculate the range, the median, and the interquartile range of the set of data that is contained within the stem and leaf plot. So let's have a look at how to calculate the range using the stem and leaf plot. So the first thing we need to do is write down our formula for range. So range is equal to the maximum score minus the minimum score. So using our stem and leaf plot, we go to the last number, and the leaf is 2, and the stem is 5. So we know that our maximum number is going to be 5.2. And then going to the first number, we know our leaf is 9 and our stem is 1. So that is going to be 1.9. So to calculate the range, we want to go 5.2 minus 1.9. The answer, or the range, is going to be 3.3. So the range of my data within the stem and leaf plot is 3.3. So next, I want to calculate the median. So because my data is already in ascending order within the stem and leaf plot, I can jump straight in and start calculating the median, and I want to look for my middle term. So median term is going to equal n plus 1 divided by 2. So I need to know how many pieces of data are within my stem and leaf plot. And to work out that, I need to count individually all of the leaves, or how many leaves do I have within the stem and leaf plot. So having counted all of the leaves, I know that I've got 35. So 35 plus 1 divided by 2. So 35 plus 1 is 36, divided by 2 is 18. So I'm looking for my 18th term within the stem and leaf plot. So what I need to do now is to go to my first number, which is 1.9, and use that count until I get to my 18th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So my 18th term is going to be 3.8. So my median is equal to 3.8. So now that I've calculated the range and the median, I now need to calculate the interquartile range. So because my data is again in ascending order, I can jump in and start my interquartile range calculation. And the first step I need to do is I need to split the data into 2. So because I've already calculated my median, I know where the middle of my data is, and it's an actual number within the data set. So I exclude that from my data set now that I'm calculating the interquartile range, and that leaves me with two halves. The first half goes from 1.9 to 3.7, and the second half goes from 3.8 to 5.2. And within each half, we'll have 17 individual numbers. So I can use that information now to work out where my quartile 1 and quartile 3 terms are going to be. So quartile term is equal to n plus 1 divided by 2, which is equal to 17 plus 1 divided by 2. So 17 plus 1 is 18, divided by 2 is 9. So I'm looking for my ninth term from the start. So I can now go and work out, starting from 1.9, where my ninth term is going to be. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So my ninth term in the first half is going to be 3.0. So quartile 1 is equal to 3.0. Now I need to do the same thing for the second half. So starting from 3.8, I need to count in 9 numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the ninth number in the second half is 4.5. So my quartile 3 is going to be 4.5. Now that I know my quartile 1 and quartile 3 values, I can go ahead and calculate the interquartile range. So making sure I write down my formula first. So interquartile range is equal to quartile 3 minus quartile 1, which is equal to 4.5 minus 3.0, which is equal to 1.5. So using the stem and leaf plot and the processes I know about how to calculate the range, medium, and interquartile range, I can calculate these values for the data set.